This is question 59 on chemistry from the 2012 IMAT. So we're asked which of the following formulae cannot be the formula for an aldehyde. So we have various combinations of C, H and O. So what we need to know here is what is an aldehyde in general. So the aldehyde functional group is this C double bond O with an H at the end. So it has to be at the end of a carbon chain, where this R group represents the rest of the molecule. So let's look at each of these and see if we can draw a possible aldehyde that fits the formula. So what about this first one? We have C6, so let's do a chain of 6 carbons. I'm going to use the skeletal formula just to make it a bit clearer and save myself from drawing. So each corner or end of a line represents carbon, and we assume that each carbon has 4 bonds around it, either with hydrogen or whatever we draw connected to it. So we have CH3, CH2, etc. Now let's add our aldehyde group at the end, because we know it has to be at the end, because there's a hydrogen. So we have another oxygen that we need to add because of O2. So how can we do this? Well, let's just put a harmless group on, like an alcohol, to account for extra oxygen. Now, all that's left to do is to see if we have 12 hydrogens. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. Pause the video and have a look if you're struggling with the skeletal formulae. So next we've got C5H10O2. So similarly, let's do a chain of 5 carbons, stick our aldehyde group on the end. Then again we've got a second oxygen to add, so let's put an alcohol somewhere. Now we just need to see if we have 10 hydrogens. So we have 3, 4, 5, 6, 7, 8, 9, 10. So this is correct. So now we have C5H10O. So similarly to this, we have a chain of 5 carbons, aldehyde group on the end, but no alcohol this time. So do we still have 10 hydrogens? Let's count up. We have 3, 4, 5, 6, 7, 8, 9, 10. So again, this works. Now what about C5H12O? Well, we've just seen that C5H10O is an aldehyde, so already we should be thinking that there's no way we can add 2 hydrogens to the structure without changing its functional group from an aldehyde to an alcohol. So this looks like it's going to be wrong. Well, let's try and draw some aldehydes anyway. So we know this can't be the case, but what if we try and rearrange it? Well, we should know that changing the carbon chain, so going from this butyl group to a tertiary butyl group, isn't going to change the number of hydrogens. We still have 3, 6, 9, 10. So there's no way we can just get 12 by rearranging the formula. So there's no way this can be an aldehyde. And finally, C6H12O. We'd hope this can be an aldehyde because we just need the one that's wrong. So we have a chain of 6 carbons, the aldehyde on the end. So do we have 12 hydrogens? We have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this last one works. And our final answer is that C5H12O cannot be the formula for an aldehyde because there are too many hydrogens. So our final answer is D.